Welcome to Burlap Teachers. Enjoy the video.
You start by writing down definitions and the identity linking them. Write gamma z as the improper integral and b, x, y as the unit interval integral. This matters because one integral transforms into the other. Once done, substitute t equals u slash 1 plus u, or use the melon transform to convert b into a product of gamma functions. Make sure to note domain restrictions re, x, re, y, 0. They justify interchange of integrals and ensure convergence for later steps. You now perform the concrete substitutions and simplifications. Change variable in b, x, y to u to separate factors and recognize gamma integrals. This is why the identity holds. Next, apply the recursion gamma, z plus 1 equals z gamma, z, to reduce arguments to known values, particularly integers and half-integers. When you encounter non-integer complements, use the reflection formula to relate gamma, 1 minus z, to gamma, z, and introduce trigonometric factors. This step resolves values like gamma, 1/2, cleanly. You finish by computing specific values and verifying results. For integer arguments, convert gamma to factorials directly. For half-integers, use gamma, 1/2, equals square pi and recursion to get gamma, n plus 1/2. Then compute b via gamma, x gamma, y slash gamma, x plus y, and compare with a numerical integral evaluation to confirm. If numbers disagree, check domain assumptions, sign errors in substitution, and normalization constants. One key troubleshooting tip: verify convergence conditions re, x, re, y, 0, and reevaluate steps.
Thanks for watching. Consider subscribing if this video helped you.